Today we're going to dive into a new technique for integrating functions called integration by parts. Now this strategy is derived actually from the product rule. So let's just remind ourselves of the product rule. You take the derivative with respect to x of some function f times g, and the derivative of that is the derivative of the first times the second plus the derivative of the second times the first. I know I'm dropping the of x here for f prime of x and g prime of x just to be efficient with my writing, but these are all functions of x. So then if I go to integrate this with respect to x, so integrate the derivative of f times g with respect to x. So I'm integrating with respect to x. I'm going to go over and integrate here with respect to x, f prime of g with respect to x plus g prime of f with respect to x. Let's think about what we get. Over here on the left, I'm taking the derivative of f times g and then I'm integrating that result. Well, that's just going to leave me with f times g over here on this side. Over on the right hand side, I have these two different integrals. So notice, well, I'll go and write that. So I've got the integral of f prime of g dx plus the integral of g prime of f dx. So I've got those two relationships. Well, what we can do is we can bring one of the functions over to the other side here, and we can express one integral in terms of the other integral. So let's just do it like this. I'm going to bring this one over. Well, actually, I'm going to rewrite this. So the integral of g prime of f dx is the same as f times g minus the integral of f prime g dx. So if I want to calculate this integral, the integral of g prime times f dx, I can do it by multiplying the two functions together and then subtracting the integral of f prime of g dx. Now when we write integration by parts, when we write the rule, we actually use different letters. We use u and v, and a slight modification in the notation. So I'm going to go ahead and write the way we use it, and I'll work an example. So customarily, we're going to call this u, and then the g prime and the dx together, we're going to call that dv. So this first piece becomes the integral of u dv. Let's move over to this other side. F was u, g is v, so this is u times v, minus f was u, so this f of u and dx, this is going to become du, and again g is what v was. So this becomes the integral of v du. Okay, so this is the relationship that we're going to use in working problems for integration by parts, but it's derived here from the product rule, this whole relationship. So let me work a couple problems to help you wrap your head around this. So I'll go ahead and erase this. We'll go ahead and work an example. Suppose we have the integral of x e to the negative x dx. So it's to integrate this. So how do I proceed? Well, I say I've got a product to do functions going on, and I've got this function here is not the derivative of that, so I'm not thinking substitution here. So I'm going to try integration by parts. So the first thing I need to do is I need to pick a u and pick a dv. So I'm thinking I'm going to try this. U is equal to x, and dv is equal to e to the negative x dx. I'm going to try that. And typically when you're picking your u, you want to pick something where the derivative is going to become constant or become less complicated as we proceed. So I'm going to go ahead and calculate du. Now du is the derivative of this, which is 1 times dx. So it'll always be du is whatever the derivative of the function is times dx. Over on this side, I'm integrating, so I'm going to end up with v. So I want to know what is the antiderivative of this. Well, antiderivative of e to the negative x is going to be e to the negative x, and then divided by the derivative of what's up there, which is negative x. So there we have it. There's v. So then let me use this rule up here. It says this integral is going to equal, so I'm going to write that integral of u to, actually, here's my u. There's my dv. So the integral of x e to the negative x dx is equal to, says u times v. So there's u times v. So that's going to be a negative x e to the negative x. And then minus the integral of v, well, this is v, so negative e to the negative x, times du. Well, what was du? Well, du is just 1 dx. So we've got that. So this is equivalent to negative x e to the negative x. This negative and that negative become a positive integral of e to the negative x dx. Well, the integral of that is just e to the negative x divided by the new power, divided by the derivative of what's up there, which is negative 1, plus the constant. So in summary, we have that the integral of x e to the negative x dx is equal to negative x e to the negative x. This will become a minus e to the negative x plus a constant. Well, maybe you're not persuaded. Maybe you think, I'm not convinced that the derivative of this is that. Well, let's see if we can convince ourselves. So let me go ahead and find the derivative of this thing. If the derivative of this thing looks like that, then I'm set. First thing I notice here, I'm going to have to use the product rule for this piece. So let's go ahead and do that. So the derivative then of this whole thing, this is my check. Derivative of the first, it's just going to be a negative 1, times the second, which is e to the negative x, plus the derivative of the second, well, the derivative of this is going to be negative e to the negative x, times the first, which is negative x. That's the derivative of this piece. Then I've got a minus e to the negative x, and then the derivative constant, of course, is 0. So notice here, what do we've got? We've got this negative and that negative make it a positive. So here I have negative e to the negative x. Here I have plus x e to the negative x. And then here I have doing the derivative of this. Okay, I made a mistake here. Let's fix it. Derivative of this, so it's minus the derivative of this. The derivative of this is this over negative 1. That makes that a positive, plus e to the negative x. This minus e to the negative x, and then plus e to the negative x. Those cancel out, leaving me with x e to the negative x, which is the integrand over here. Okay, again, when I was doing the derivative of this, and the minus out here, the derivative of this was e to the negative x divided by negative 1. That makes that a positive, and all those cancel out. So yeah, it checks out. Let's go ahead and work another example. By the way, this was number 6 on your worksheet. This one is number 4 on your worksheet. It's the integral of the natural log of x dx. So initially, this looks a little confusing. We only see one function. But I'm going to go ahead and pick this as my u, and I'll pick this as dv. So I've got u is equal to the natural log of x. dv is equal to dx in this case. So the derivative of u, or the differential du, is equal to the derivative of this, which is 1 over x, times dx. Over here we integrate, So the function whose derivative is dx is just x. So this is v is equal to x. All right, so now what? Well, we plug it in here. So we've got the integral of ln of x dx is equal to u times v. So it's going to be, there's my v, so there's my u. So x times the natural log of x. I did it reversed so that the x's weren't stacked up back here in the back. So x times ln of x minus the integral of v, which is x, du, which is 1 over x dx. Well, what happens here? The x's cancel. So I'm left with x ln of x minus what? The integral of 1 dx. Well, that's just x. So I get x natural log of x minus x plus a constant. Now, let's convince ourselves that we're all right. Let's check it by finding the derivative. Okay, we're going to find the derivative of this. We're going to have to use the product rule. Derivative of the first is 1 times the second, which is natural log of x, plus the derivative of the second, which is 1 over x times the first. That's the derivative of the first piece. Now the derivative of this little piece right here is just going to be a negative 1. And the derivative of constant is 0. So this is just natural log of x. X divided by x is going to be 1 plus 1 minus 1. Those cancel out, and I'm left with natural log of x, which was the integrand. That's our second example. Let's do a third example, because sometimes you have to repeat the integration by parts multiple times. We'll look at an example that will work for us to do that. All right, so here's our function here. Again, we typically pick for u something whose derivative becomes simpler as we take the derivative, often hoping to get it to a constant eventually. And for the dv, we want something that's easy to integrate. I do know how to integrate this. So this will be our dv here. This will be our u. So we're doing u is equal to x squared. dv is equal to 2 to the x dx. And what function has this as its derivative? Well, that's just going to be 2 to the x divided by the natural log of 2. Over here, du equals 2x dx. So now I'm going to rewrite this using my integration by parts here. So the integral of x squared times 2 to the x, 2 to the x dx is u times v. So that's going to be x squared times 2 to the x all over the natural log of 2 minus the integral of v. Well, this is v. So it's going to be 2 to the x all over the natural log of 2 du. du is 2x dx. Well, what do I do now? Well, I don't know how to integrate this as written, so I'm going to have to do integration by parts again, second time. So let me make this a little bit easier for myself. I'm going to go ahead and rewrite this and factor out the 1 over the natural log of 2, just to make it a little easier here. So this is 1 over the natural log of 2 times x squared times 2 to the x, bringing that out here, minus the integral of 2 to the x times 2x dx. Again, I've factored this out way in front of the whole thing. So now I'm looking just at this little integral here. So let me just treat that one separately. The integral of 2 to the x times 2x dx. And I'm going to integrate this piece separately, but I'm going to do it using integration by parts. So this time, I'll pick u to equal 2x and dv to equal the 2 to the x dx. Derivative or the du here is the derivative of this, which is 2 times the x. I want to find the function whose derivative is 2 to the x. That's going to be v is equal to 2 to the x all over the natural log of 2. So I'm going to go ahead and do my u times my v. There we are. So I've got 2x times 2 to the x over natural log of 2 minus the integral from v, so that's this 2 to the x all over natural log of 2 times du. Well, du is just 2 dx. I'll be able to integrate that. Let me go ahead and simplify this piece. I've got 2 to the x times 2 to the x over natural log of 2. I can bring this 2 and that natural log of 2 on the front. So this is 2 all over natural log of 2 times the integral of 2 to the x dx. And I know how to integrate that. So this is going to be 2 to the x times 2 to the x. This is 2x times 2 to the x all over the natural log of 2 minus 2 over the natural log of 2 times the integral of this is, well, that's going to be 2 to the x all over the natural log of 2, then plus our constant. We've got a lot of pieces we need to put together there. So all of this work is just this piece. So I'll need to plug that in. So let me go ahead and erase and make some space, because I'm going to consolidate. So what I have here is 1 over the natural log of 2 times x squared minus 2 to the x. And then this entire integral, I said, is all of this. So let me go ahead and write that in there. So it's minus, oh, and this was a times, by the way. This was a copier, times. So times right there. Minus all of that. That was this 2x times 2 to the x over natural log of 2 minus 2 times 2 to the x, and then that's over natural log of 2 here, and then that's over natural log of 2 there, plus a constant. Okay, let me see if I can clean that up a little bit. Just double checking to make sure I've got all my pieces. I've got this piece, and I've got those pieces together there, and I've got my constant. Let me go ahead and write this constant out here at the very end. You know, if there are other numbers along the way, we're just going to add those all to that constant. All right, so can I factor anything out, anything that appears in common? Well, I notice here that the 2 to the x appears everywhere. So I'm going to go ahead and factor that out here to the front and see what that leaves me with. So I'm going to have 1 over the natural log of 2. I'm factoring out that 2 to the x. That leaves me with this piece is going to be x squared. For this piece, it's going to be minus 2x all over the natural log of 2. And for this piece, it's going to be minus 2 all over the natural log of 2 squared. That's what we saw there. And then plus the constant. So here it is. There's the final result. The derivative of this lovely function is that. All right, let's check. Convince ourselves that that is in fact. Okay, this is going to be fun. So we're going to have to use the product rule. We've got one function times another function. So I'll do the derivative of this. Again, the derivative of that is going to be 1 over the natural log of 2. That's out there in front. Natural log of 2. The derivative of 2 to the x is the natural log of 2 times 2 to the x. That's nice, because that first, that natural log of 2 is going to cancel out here. That's right. So this is the derivative of the first times the second, which was all of this. X squared minus 2x over the natural log of 2 minus 2 all over the natural log of 2 1b squared. And then, of course, the derivative of our constant is going to be 0. We'll throw that out right now. So this was the derivative of the first times the second, plus the derivative of the second. I need to find the derivative of all this. Derivative of x squared, of course, is 2x. And the derivative of negative 2x over natural log of 2 is minus 2 all of the natural log of 2. And then the derivative of this constant is 0. So it's just going to be this. So this is the derivative of the second times the first, which was 1 over the natural log of 2 times 2 to the x. Okay, so I've got all this and all this down here. Let's see what we can do. Well, I notice some things here, but we'll deal with that in a moment. First of all, these natural log of 2's are going to cancel out. So this is just 2 to the x times x squared minus 2x over the natural log of 2 minus 2. Here I've got a 2 to the x as well. So I'm going to just make note of that here. This is 2 to the x. Let me go ahead and bring this 1 over natural log of 2 inside there. So I've got, when I bring this 2 to the x, rather this 1 over natural log of 2 inside and multiply it there, I've got 2x all over natural log of 2. And then I bring this inside here, I get minus 2 all over the natural log of 2 squared. And we've got 2 to the x all out in front. Notice this 2 to the x and that 2 to the x. I can bring that out in front and then combine all of these values. Let's see what we've got going on. I've got negative 2x over the natural log of 2. But then I have a positive 2x over natural log of 2. So when we combine them, that'll go to 0. And let's see what else we had. I think I did a copy error on this. I forgot to write the over the natural log of 2 squared from here. I forgot to bring that down. There it is. So let me look at these values. So this, actually, they're looking like they're the same value. I'm expecting them to be different. So I might have made an error. So let me go back and try to figure out where that error might be, because I'm expecting those two quantities to cancel, and they don't. And so that's a problem for me. And I see my error. So let's go back and catch my error. So notice here I have a negative here and a negative there. This negative times that negative should make this a positive. But I did not write it as a positive, so I'm going to fix that. Makes that a positive. That comes over here, makes this a positive. So then it was the derivative of the first, which was all of that, times the second, plus the derivative of the second. So this should be a positive times the first. So this becomes a positive. Now this and that cancel out. And so we're going to get down to just the 2 to the x times x squared, which was what we have at the start. So it checks. So although I didn't intentionally make this error, it's actually a very beneficial that I actually made that error, so we can illustrate that by checking, you can detect errors, because if it's not coming out the way you expect it to, either your derivative is wrong, rather your derivative is wrong, or you made an error over here. In my case, I made an error. The negative times the negative was to be a positive, and I missed that. That was a copy error. As I came down, but I was able to detect that error over here and go back and say, oh wait, it's not turning out the way I expected it to. Let me go back and see where my error was, and there it was. I missed that. All right. So these are challenging. These are hard. So it's going to take some practice to get used to it. In terms of picking, you tend to pick the thing that's going to have a derivative that will become simpler as you go. For a DV, pick something you know how to integrate. And sometimes you'll pick U and DV and it just gets messier as you go forward. And in those instances, you often back up, go try something else. So have fun and happy learning.